So we have talked about in function. We have talked about domain. We have talked about range. We haven't talked about different properties of function. Okay, not just property, I mean the types of function that we say. So in last class, I told you the function is some sort of mapping. We map a set of things to another set of things, and it makes our lives easier. So there are few things that you should know. One thing I would say injective function, another one is subjective. Then you need um, onto function. You guys know what is bijective function? And there is also called many to one. What is injective function? Do you guys know that? We call one-to-one mapping. So if you have a function, okay, which maps each element from a particular set to each element on another set, then it is called, sorry, my definition was wrong. What I said, that's not correct, guys. I need to say that when you map each element of this set to only a unique element of B, I do not have to worry about that each element of B should be mapped. Okay. I just need to worry about that each element of A should be mapped to only one element of B. Then it is called one-to-one function, or you say injective function. You got it? So your definition should be very precise. Preciseness that I'm sure you guys are getting. And if I have one element left here or left here, I do not have to worry about it, because I'm not mentioning that all element like such X belongs to A. That is there. I do not have to worry about all Y. I mean, this is totally wrong. What exactly do I mean when I say I do not have to worry about each element in B? This means that I'm not saying that this is bijective. When I say that the definition of bijective, I apply that, that means that my codomain is also equal to range. Okay, right now I'm not saying anything about codomain or about range. So the point is that each element of A only should be mapped to a particular element of B. That's the definition of injective. When you say that many to one you're defining, that means that many to one, that means that if you have at least one element which is at least one element in set A which is also mapping to a particular element in B which has already associated with an element in A. So what exactly essentially it is saying? It is saying that if you have two elements in A that is leading to actually just one value. So I'm sure you guys know the function y equal to x squared, and if you take y equal to 4, then your x is going to be -2 and 2. Then this is basically many to one function. And you also know that the property that many to one is actually because if you have, so you're then basically you are saying that if you have element -2 and 2, then these two are going to map to the same value in y. That's what you're saying. So that's how you know that this is many to one.
So this is bijective.
Every element in set A is related to no, it is not. How this is not bijective? I'll tell you. So your y is also on R, right? This is R, but you do not have any element in X which is actually mapping to -infinity open to 0 open. Yeah, you got it.
Okay, so codomain is not equal to range.
Yeah, so codomain is not equal to 2, basically. That's what I meant. So I'm saying that minus infinity to zero is still in your range, still in your codomain, but it is not range. That's what I meant. Now, what do I need to talk about? I mean, you guys know onto function, you guys know injective, bijective, anything else? Yeah, just give me a second. That would be helpful. I don't know if they ask these questions still or not. I have no idea. They ask trickier questions in function. That I know. Okay, let's do composite. Let's do composite and let's do some tricky problems. So, guys, what exactly composite means? Composite is basically constructed by nested, it comes from nested property. I call it nested, many mathematicians call it nested. What exactly it means that if you have a mapping sort of defined from A to B, and there is another mapping from B to C, right? Then you can construct FOG as such. Um, yeah. So, sorry, A2, the mapping is going to be G of X is B to C, then you have input C. Yeah. Then your mapping should be in F of F, F of, your F should be defined as this, guys. Yeah. So how do you, actually, how do you imagine the mapping? Your imagination should be that if you have constructed a composition of two functions, then whatever inside this G, so G is here mapped on B to C, right? So it is giving you C basically. I mean, this is a set, this is another set, and the function G is basically a unique kind of mapping from B to C, and this that is going to give you C. I mean, the set C. So your C is also mapped from your C is actually mapped to A using this unique relationship that is called F. So if you take F, sorry, if you take F of G, then it should give you output A. That's what it means. So that's how we define the composition. You can just take any combination. I mean, this is one way I have defined. You can take any other combination, like you take G as A to B, and you take F as B to C. That's how you can also do it. Because basically, you are saying that what exactly the inside uh, property or nested property that I meant was if you have a function inside this outer function, then basically its range is essentially the domain of this f. Its range, I mean the range of g of x is basically the domain of f. So that's what it means in technical terms. That's what the nested property is. So tomorrow I can define f of g of h of I sort of x, something like that. I can define anything. So what exactly it is going to be? So my I should, suppose my I is mapped on A to B, my h is mapped on B to C, my g is mapped on C to D, and my f is mapped on D to E. So basically, I'm reaching from set A to set E. That's what this is giving me. So yeah, That's how you define the composite function. But you don't have to worry about these kind of nested functions because it's too lengthy. You just need to think of maximum two composition, something like this. So let me give you an example. I think, yeah. So let's say that if you have a function f of x equal to 1 upon x plus 2, g of x equal to x upon x minus 3, then someone can ask you that define f of g of x. What would be? So you just plug at x, you just plug it this whole gx. So first thing you write at x position, you write g of x plus 2, and then you substitute g of x with the given this value x upon x minus 1, x minus 3. Then you calculate. So whatever you will get, I guess, x, 2x, 3x minus 6 upon x minus 3, if I'm not wrong. That's what you're getting, guys? No response. Come on. You guys understood the concept of composite?
Yes, sir.
Cool. What
Yes.
exactly does it mean?
A function depends on another function,
A function?
depends on another function.
No. I explained it like I thought I explained it much better. Oh, wait, what is happening? Uh, yeah, are you guys able to look at my screen?
Yes, sir.
Cool.
Yes.
Sorry. Yeah, sorry about that. What I was saying that I thought I explained it better. Anyone else want to take a shot on this one? Mansi is so quiet. What happened to her? I want to hear her opinion on this. What exactly composites mean?
No, uh, uh, I can't explain it in a like in mathematic language. I can.
Yeah, you can explain in maths. No problem. Just tell me what exactly it means.
When you put the value of one function into another function and find a function like find a new function like from a to b, you put the value of b in a and then you reach to c. Like I can't explain it. Like
No, it's totally fine. You are very. I would say you have done a good job. Uh, yeah. So the man like Mansi, what she said, I'll just rephrase it a bit. So what exactly she's saying that if you have a mapping from defined mapping from one set to another set, and the another set that you have got, it is also there is also another mapping defined on that, then you can just compose these two mapping, right? That's what composition means. So in terms of function, see, in terms of function, what she said, that's totally fine. That's exactly what it means. So uh, what she said that if you have one function and you are just defining, you have another function, you are just defining that function into another function. So that's what it means. I mean, that's an absolute answer, guys. So nothing further. What exactly did I do here? I just give you an example. You took f of x, you took f g of x, and I wanted to get the composition of f of g of x. Then what exactly do I do? I substitute x with g of x, and I then substitute g of x in terms of whatever it was, x upon x minus 3, and I get f of gx. So yeah, that's all. That's all about composite function. I wanted to do some sort of problem which has been asked in D school or ISI. It has been a tricky question. So let's do that. And I think I'll move forward on limit tomorrow and graph as well. I thought I would finish them today. Let's do it first because yeah. So I'm writing some sort of problems. Just solve it right now. Do you guys know greatest integer function, least integer function? Guys, do you guys know GIF or SIF?
No, sir.
Okay. You guys have noted it down?
Yes, sir. X square minus
These type of questions every year they ask. I don't know what exactly do they see in this one. Someone is unmuted. Can you please mute yourself?
So what is in the third question 8x plus 3?
Is satisfied where fx is given bx squared plus cx plus d.
That is. Okay, I thought it's.
No, no. My handwriting is so poor, guys. So
For the fourth one,
yeah.
fx
Fourth one
is
is
equal
Fourth one is f of 0 equal to 2, f of 1 equal to 3, such that, I mean, these are semicolons, such that f of x plus 2 is equal to 2x minus f of x plus 1 minus f of x plus 1.
Sir, the answer of second is 3.
Question number 2 is that okay? I have no
Should be
idea.
minus 3, right? It's or plus
I have
3.
no idea what answer is. Could you guys just tell me again? What was the answer? One person tell me, then I'll yeah. What is the answer of second one?
3.
I'll note it down. Yeah. So one person said 3. What about others?
So I got minus 3 for this one.
And another one got -3. Okay, let me just calculate it.
Sir, answer to first one is 2 of f of x into f of y.
Yeah, who answered this one? I
Teacher
want to know.
Jarna.
Amazing.
Thank you, sir.
Guys, you want to check the second question again? I think Nitigya and Mansi. Where is the question? I think Mansi answered 3, right?
So,
Good. Shall I wait or I should move forward? I'll just solve it one by one. So let's start with the second one because it's quite simple. 2 of f of x plus 3 of minus x is equal to x squared minus x plus 1. What exactly you do? Whenever you get these kind of subjugate, what exactly you do? You replace x with minus x. What do? You replace every x with minus x. So first write 2 of fx plus 3 of minus f of minus x equal to x squared minus x plus 1. This is going to be your equation 1. When you replace f, x is going to be replaced with minus of x plus 3 of f. Minus of minus x going to be x. Now if you take minus of x squared, that is x squared minus minus plus x plus 1. This is equation 2. What exactly do? You need f of x, right? So either you just solve for f of minus x or f of plus x. So I want to solve for f of x, then I need to just multiply with some numbers so that and subtract them 1 to 2 so that these term f of minus x just cancel out. So what I do, I just multiply with 1 into 2 and minus 2 into 3. So what exactly do I get, guys? I get 4 of f of x plus 6 of f of minus x. That is going to be 2 into x square minus 2x plus 1. And if I multiply with this one, then I'll get 6 of minus of x plus 9 of f of x is going to be 3 of x squared plus 3x plus 3. You guys didn't point a mistake. That should be 2. Yeah. This is I'm taking minus. This is I'm taking minus. This is minus. So 4 f of x minus 9x, this cancelled out, this cancelled out. Minus of 5 f of x, that is going to give me minus x squared minus 5x and minus 1. F of x, if you take minus sign common, you will get x squared plus 5x plus 1 divided by 5. Now I'm asking you to calculate f of 2, plug x equal to 2, 2 to the power squared plus f of 2, 5 into 2 plus 1 divided by 5. You get 4 plus 10 plus 1 by 5. What exactly do you get? How simple was this? So Mansi was right. Great job. Any doubt in this one? Or anyone got the same answer? Was I too fast? Come on, guys, tell me.
So can you show the solution again, the bottom one?
Yeah, yeah. Okay,
So
I'll scroll
after the
it.
multiplication.
I'll go through it once again. Okay, just step by step. First thing, when you have these kind of subjugate problems, I call it subjugate because you can see that here x is positive, here x is negative. Okay, and if they are in combination, then I call them subjugate. Do not use this term frequently. I mean, you don't have to worry about these kind of things. So if you just think, if you just have this kind of problem, what exactly you do? The step one is basically you replace x with minus x. That's first step. Second step, you just the first equation that you are given with, that is your first equation. So you have that first equation. When you replace x with minus x, you get your second equation. What exactly do you do after that? You remove the term which is extra. So your f of minus x is extra basically. So because you want to calculate f of x, right? So I wanted to remove f of minus x from this. So what did I do? I did some sort of manipulation. I mean, multiplied in equation 1 with 2 and multiplied equation 2 with 3, and then subtracted these two, and then I got an expression for f of x. Are you able to understand this point? Any doubt at this point? Just tell me.
No doubt.
Cool. So when you do some sort of manipulation, you get f of x. That is going to give you x squared plus 5x plus 1 upon 5. Now you just set x equal to 2. And you get the value of f of 2. That's what you were asked for. Cool. Okay. If anyone wants to note down the solution. Once you are finished, just let me know.
Sir, answer to fourth one is 13.
I have no idea, kid. Just I'll note down your answer, Jharna. Jharna, right?
Yes, sir.
Cool.
Yes, it's coming 13.
Cool. So 2 people, 13. Nitik, yourself, Jyoti. Let's do the fourth one because they have already answered it. So yeah, f of 0 equal to 2, f of 1 equal to 3. You guys noted down the last question, right? Question 2. You guys have noted it down or not?
Yes.
So you guys already know how to solve this if you're, I mean, if you are getting the correct answer. I mean, I had no idea that you guys already know. So if you have iterative things, this is called the iteration, and we call it recursion. I am telling you this because in macroeconomics you are going to use a lot, and even if you'll do macroeconomics in future. So what is recursion? Recursion type of problem is, so basically we use back substitution here. Computer science use this word a lot. So you're given with f of 0 equal to 2, you're given with f of 1 equal to 3. So if you just plug x equal to 0, set x equal to 0, you get f of 2 equal to 2 of f of 0 minus f of 1. Now you already know f of 0 and f of 1. Then you what exactly you do? You substitute the values that you're given. So you get 2 into 2 minus 3, that is 1. So you get f of 2 equal to 1. Now you need to get another value. And after 2, because this is in discrete, then what exactly do you need to do? You're taking a step, 2 plus h. Your h is basically 1. So x equal to 3. I mean, sorry, x plus 2 equal to should be 3. Then x is basically a step value, not the extra one. Just let me delete this one. Yeah, so your x is basically the step. So your x is basically first, 1, right? And if you plug x equal to 1, then you will get 3 here. When you will get 3 here, you will get f of 1 here and f of 2 here because it is x plus 1 expression. Then you calculate f of 3, then 2 into f of 1. What exactly your f of 1 is? 3, because it is given. What you calculated in the last step, that is still back substitution. This step is called back substitution. And you plug f of 2 from this last step or last part, that is 1. So you get 5. Similarly, you calculate f of 4, that is going to be 2 into f of 2, because you are setting x equal to 2 minus f of 3, and your f of 2 was 1 minus, what is your f of 3? 5. So you get minus 3. My f of 5, that's exactly what we need to calculate. So you get 2 into f of 3 minus f of 4. What is f of 3, guys? 5 minus 3. So you get 13. Very good. So 13 is the answer. Any doubt in this problem? It's quite easy, just recursion and back substitution. Questions, doubt? No doubt. Question number 3. It says find the values of b and c such that f of x plus 1 minus f of x equal to 8x plus 3, and this is the expression. Okay. Let me just see again. Yeah. Anyone got the answer for this one? Anyone find value of b and c?
Sir, can you show the question again for this?
You guys haven't solved it. Attempted this part. I mean, question 3. You guys have attempted it, right? I have give you enough time.
I was able to solve only 2 and 4, not the third one.
Jharna,
No, sir, I haven't tried that yet.
try it. Try it. Just 2 minutes. Try it. I'm here.
Okay, sir.
Be quick.
B is equals to 4.
Yeah, B. I have got 4.
Okay. C, C will be -1.
Just give me a. Just give me a second. You are doing on copy. I'm. Um,
Yes, sir. C equals to
yeah.
-1 and B equals to 4.
Yeah. It is. It is. Mhm. So what exactly you guys have? I'm sure you guys just use this expression bx squared plus cx plus d, substituted x with x plus 1, and solved this expression,
Yes.
this whole one. That's what you guys did. If you guys don't have any doubt, then I would like to skip this one. Why should I waste time? Anyone who was not able to get to the answer, so B is going to be 4 and C is going to be -1. That's what I also got. Nitya and everyone else. Guys, anyone
Can
couldn't
you
reach
explain the first one?
first question?
Yeah, I know the. I think that's the problem.
This
But
one? No. This one I'm going to do that. Don't worry. You're talking about the first question, right? Wait.
yeah,
This. Yeah, I'm going to do that. Don't worry about it. I'm talking about if you want me to do third problem. That's all. Anyone? Okay. So everyone got the answer. F of x is given as a to the power x plus a to the power minus x divided by 2. And I need to find f of x plus y plus f of x minus f of x minus y. Okay, so what exactly you do? You replace the expression with your expression is going to be minus of x plus y divided by 2. That's what you have. Two. You just segregate them, ax, ay, a minus x, a minus y. Since the denominator is same, then I write this as a to the power x into a to the power minus y plus a to the power minus x into a to the power y divided by 2. Okay, then what exactly do I do? I take like things together. So if I take a to the power x terms together, then I get a to the power y plus a to the power minus y. If I take a to the power minus x together, then I get a to the power minus y plus a to the power y. This is some sort of factorization that I'm doing, or this is the basic thing that you should always do in these kind of terms if you get that these kind of questions. These kind, I mean the kind where you have exponential or where you have logarithmic or trigonometric, something like that. And it is asking you to find an expression, some sort of manipulation in the expression. So here, what exactly the manipulation that they did? They gave you a function and they asked that, okay, if I replace x with x plus y or x minus y, then what exactly am I going to get? Usually these kind of things always has been asked. So the question is that the intuition, your intuition should be that you should always keep this in mind, that you should be able to identify like terms. So here the like terms are a to the power x and a to the power minus x. I took together, I got this one. Now what I can do, I can write a to the power minus this term. I mean factorize. Now I'm taking this part common. Then I'll get this into a to the power y plus a to the power minus y divided by 2. Now, if I multiply in the denominator by 2 and in the numerator as well, then I will get 2 into a to the power x plus a to the power minus x divided by 2 into a to the power y upon a plus a to the power minus y divided by 2. This is basically your f of y, and this is basically your f of x. So that's what I think Jarna got. She got 2 into f of x into f of y. And your expression that you started with, that was f of x plus y plus f of x minus y. Any doubt?
No, sir.
Cool. Nitigya, question.
No, sir, I got it too. It's clear.
Sarvjyoti, question.
Clear.
Clear, good. Mansi, Dipanshi.
So, मतलब आ गया था ये वाला.
Okay, cool, cool. Very good. Who spoke and who didn't?
Mansi.
Okay, Dipanshi is not here. Cool, guys. So these four questions are done. I think you guys are pretty much efficient in doing these kind of tricky questions. Okay, so I'll kick it off from this. I'll give you an intro of limit right now. I don't want to miss that because, yeah, that would be too long. So let's start with limit intro. So the concept of limit is the idea of limit comes from tangential. Like if you have a function, okay, and you draw a tangent at a point, then you want to know that whether this tangent is going to exist or not. I mean, that's what we do in derivative. So the whole idea that Newton had in his head, it was actually tangent. He wasn't looking for limit that time because he was checking that, okay, the rate of change in something with respect to something, what it is going to give me. It started from there and it ended on the other side. I mean, it ended on the limit and continuity, and he defined all these things on the latter part of his journey. So the basic idea of limit in at a function in a function f of x at a point x tends to a. Why am I saying x tends to a? So there is this word that you guys are going to use in mathematics a lot. A lot. I mean, when I say a lot, I mean at every point in microeconomics and mathematics, you are going to use this word, arbitrary clause. So what exactly does it mean? It means that if you have a point in your domain, or not even in domain, it doesn't matter. If you move slightly, just epsilon distance any side, okay, then you are saying you are in the neighborhood of this point, or you are arbitrary close to this point. So what exactly do I mean? I am saying that I am not reaching, if I take the value a equal to 3, then I'm not saying that I'm exactly taking 3. I'm saying that I'm some point 2.999998, something like that. So that's exactly what arbitrary close means. And you will encounter this word a lot in real analysis and calculus as well. So if at x tends to a, f of f, whatever the value of f of x you will get, that is going to give you limit. So I hope the concept is clear. The idea is that when x is arbitrary close to a, then fx is arbitrary close to L, till L is limit of, ध्यान देना इस wording पे, L is limit of f of x at x not equal to it. People say it every time that they are wrong. X approaching a. If you guys know David Jason, he would be really pissed off on if you say that x is equal to a. And I don't know if you guys have watched his lectures or not. Yeah. So the wording should be clear. I mean, the preciseness in your head, it should be very, very clear what exactly it means that you have some sort of function, and I told you to find a limit at this a, then you are not exactly going to, even if it is continuous. Okay, you don't have to worry about that. Limit definition just says that you are not closing this value, you are just approaching this value, and your f of x is approaching some value L from this side and this side. Then you say that L is the limit of f of x at x approaching a. That is the wording. So remember this. This is not difficult. And then the concept of right-hand side limit and left-hand side limit. Limit comes from here if you are approaching a from right side, or if you are arbitrarily close somewhere here. Okay, then you say that this is RHL. I mean a plus, then you are in a minus, then this is LHL. That's what it means. I mean the same definition. If you just define x approaching a, x approaching a plus, or basically you are saying that x is arbitrary close to a from right hand side, then it is going to be right. L is going to be right hand limit of f of x. Similarly, if you're approaching a from left hand side, then you're basically saying that your f of x, the limit L is basically LHL or left hand side limit. So that's what the definition is. I just want to make a concept very, very clear that people always actually get confused. Your a is not necessary to be part of your domain. So why am I saying this? So remember, we did an example x minus 5 upon x plus 3, and we made the graph of this. You guys remember that? We did in today's lecture,
Yes, sir.
right? And we knew that minus 3 is not in the domain. But we also calculated minus 3 plus, I mean limit at minus 3 plus and limit at minus 3 minus, right? We did that. So the point should not be in your domain. I mean, it is not necessary that point is going to be in your domain, then you can calculate limit. It is not. That is the first point. Second point I want to make. Your LHL and RHL exist and they are equal. Then you say limit exists. Now, ध्यान देना इस पे. What I'm saying that if your left-hand side limit and right-hand side limit are equal, then you say and are equal and they exist, then you say that basically, wait, I lost one more thing. Equal and finite, because your RHL limit and LHL limit both can be infinity as well. And there is no sense of infinity in our mathematics system. I mean, we haven't built a real number system where you can say that, okay, infinity making sense. But yeah, here in our numbers, the real number system that we have built, and there is no sense for infinity. So forget about that. If your LHL is equal to RHL, and if the existence of LHL and RHL has where it is coming from, it is coming from finiteness. I mean, let's say that your LHL is also 3 and RHL is also 3 and they are equal. Then you say, okay, limit exists for this function at point A. And the limit value is 3. If they are not equal, even if they exist and if they are not equal, you do not say that limit exists. I hope I'm making sense.
Yes, sir.
Cool. So you do not say that limit exists in that case. That's the first thing. Second thing, you do not have to worry about f of a. So limit x tends to a minus f of x equal to limit x tends to a plus f of x. This is the only thing that you need to worry about. Is equal to L, where L is finite. If they are equal, then you say that limit exists. Now, if you say that f of a is equal to this, fine. I do not know. You do not have to think about f of a right now. Just it's a different concept. Okay, I have just defined that limit is actually the value of f of x when f of x is arbitrarily close to L at x approaching a minus and a plus. That is what L is. F of a when f of a is that value when x exactly is a, nothing else. Okay, so your x is actually taking the only one value. That value is a, nothing else. So your x is precise. It is not arbitrary close. It is not moving right hand side or left hand side. It is precise. The more preciseness word that you can use. I mean, it is exactly taking the value a and the value that you will get after putting in the function. That value is going to be f of a, and limit is not defined that way. So limit is defined the way that I have told you. It is defined that if you are taking any value arbitrary close to a, then the value that you will get from f of x, and if they are equal, I mean left hand side and right hand side limit, both values are equal, that means that limit exists. That's what existence of limit about. So look how beautiful is this one, right? That's all today, guys. And I'll stop sharing my screen.